Welcome back to another video on the topic of system of equation. Let's continue. We have 20 fifth graders that are in their birthday party. Each child got to choose between miniature golf or bowling. Cost of playing miniature golf is $4 and cost of bowling is $6. The total cost of the party was $96. How many children playing miniature golf? Now, pause the video for a second and answer this question to yourself. I know how to solve this problem because I've created the video. What is a variable in this problem and what is it that we're assigning X and Y to? Okay, both my questions are essentially the same. Either you need to know what are the variables or what is it that you're assigning X and Y to? Are you assigning X and Y to the 25th graders because they played different games? Are you going to assign X and Y to golf and bowling? Are you going to assign X and Y to the $4 and the $6, which is the cost of playing the game? Think about it for a second and then proceed. If you're still confused, continue watching the video. All right, the answer to that question is golf and bowling. Again, as I've always said, the composition of those two are different, right? Golf and bowling are two different games, right? How much money you pay is not necessarily a variable, right? Or how many kids play each of those games is also not a variable. It's their personal choice, not a variable, right? So let's say X corresponds to golf and Y corresponds to bowling. Okay, I'm not going to call it miniature golf and all that, just golf. Okay, we know the total number of kids playing golf is X plus Y equals 20, right? That's just a physical count of how many kids playing golf and bowling is 20, okay? But $4 is assigned to golf, right? So 4X, and bowling is assigned to Y, so 6Y. That's equal to $96. Now it looks like a familiar expression that you can solve. Let's say we multiply both the upper expression by 6 and the bottom expression by 1. And I've provided a rationale on why I do that in one of the previous problems. So go back, rewind it, watch that, come back and solve the problem again. So that'll be 6X plus 6Y equals 120. So 4X plus 6Y equals 96. That's 2X equals 120 minus 96. What is that? That's 24. And therefore X equals 12, right? Right? So that means what we're essentially saying is 12 children had played golf, right? Essentially, the children is part of the goal. The children connects the golf and the bowling, right? Right? That is what is defined precisely by one of the two expressions, right? Sorry, this is children. That's what I meant to write. The children connect the two games, right? Which is why we gave a head count expression. So we know the total count is 12, right? So 12 plus Y equals 20. So Y equals 8, right? Now let's see which one was assigned to what. The children that played golf are assigned to X, and children that played bowling are assigned to Y. The question asks how many children played golf. That means we have to look at the value of X, which I've already said, but I'm just re-emphasizing it. So X is connected to golf, and golf is connected to children. So that means 12 children have played golf. Does that make sense? Okay. Let A be the point of intersection between the lines given by the equations. So and so, what is the slope of the line that passes through that point and the origin? We know from fact that when the two lines intersect, that means we can, if it is simply given in, you can do one thing, you can convert both expression in terms of Y, and then you can equate it that'll give you the same answer as if you substituting one and the other, okay? So what I'm saying here is 2x minus 5 equals 4, 4x minus 7y equals 9, right? So essentially you can convert y in terms of x. So 4x equals 9 minus 7y, and x equals 9 minus 7y over 4. You can do this method, okay? Or you can simply substitute x back in here in one of the expression and find y. That's one. So if you call this expression 1 and 2, you can substitute the x value of x into this expression. Sorry, this is 9 plus 7y. So I was talking and made that error. And then calculate the value of x and then find y. That's one way to do it, okay? The other is what we've been doing, 2x minus 5y equals 4, 4x minus 7y equals 9. We can multiply this expression by 7, this by 5, if my intention is to cancel out the y term. So that's 14x minus 35y equals 28. Again, 5 times 4 is 20x minus 35y equals 45. So if you subtract expression 3 and 4, if you subtract 3 from 4, then that will give us 6x equals 45 minus, 28? That's 17, right? So x equals 17 over 6, right? Now let's take the x value and substitute it in expression 1 or 2, doesn't matter which one, and then you can get the value of y. So 2 times 17 over x minus 5y equals 4. So that means 17 over 3 minus 5y equals 4. So negative 5y equals 4 minus 17 over 3. If you take 3 as a common denominator, that will be 12 minus 17 is negative 5 over 3. Negative 5y equals negative 5 over 3. So y equals 1 over 3, right? We know our x and y, right? And then the line passes through the origin, right? So if you call x, what is solved here as x2 is 17 over 6. And what we solved for y as y2, 1 over 3. And x1 is 0 because it passes through origin. X2 is 0 because it passes through origin. Y2 is 0. Y1 is 0 because it passes through origin. And slope is y2 minus y1 over x2 minus x1. Because it's just 0, you don't need to worry about it. So it's essentially 1 over 3 over 17 over x. You know how to do this, right? I know it's been a while since we've done ratios, but 1 over 3 times 6 over 17, this is 2, so it's 2 over 17. Does that make sense? I know it's a lengthy problem, but it's not a difficult problem. And I can't think of really any particular area that you need to struggle with, except you need to know the equation for slope. Okay, where do these lines intersect? We just did a problem very similar to this one before. These are the two expressions. If these two lines intersect, that means 3x minus 6 equals 2x plus 5. So x equals, 11? Okay, if x equals 11, what is y? Y equals 3 times 11 minus 6, that's 33 minus 6 is 27. Yep. So they intersect at 11 and 27. That's it. Does that make sense? Okay. All right, let's continue. At a carnival, hamburgers cost $4 while hot dogs cost $2. Becky has to buy 18 items for her students. She spent a total of $48. How many hamburgers did she buy? Again, you want to pause the video, ask yourself how you're going to assign the x and what are the connecting ways that which x and y are connected. Write the algebraic expression. If you can't do it, and you still feel like I want to watch this problem again, maybe I'll do the next one, just continue watching, right? So the physical count is 18 items, right? So hamburgers, let's say, is X. Again, those are two different food items. They're different composition. So hot dogs will be Y. This is what I'm assuming. You could have assumed X to be hot dogs, Y to be hamburgers. That's absolutely correct. You can do that. So physical count of hamburgers plus hot dogs is 18, because that's 18 items. Let's count, okay? And we have assigned hamburgers to X, and so hamburger cost is $4, so it's 4X. Plus hot dogs cost $2. We assign hot dogs to Y, so that's $2. So sorry, 2Y equals 18. You can multiply the upper expression, sorry, by, so this is 48. Okay, you can multiply the numerator by 2, or sorry, the top expression by 2 or 4, depending on what you want to cancel. Let's say I can multiply by 4 and the bottom by 1. What I'm trying to cancel here is X, so it's 4X plus 4Y equals 18 times 4, isn't that 72? Yep, 72. And the bottom stays the same because I'm only multiplying by 1. So that means X cancels out. If you subtract, let's call this expression 1, 2, this is 3, and 4. Subtracting 4 from 3 will give you 2Y equals 72 minus 48 is 24. So Y equals 12. Okay. Question asks, how many hamburgers did she buy? Y corresponds to hot dogs, right? So 12X plus 12 equals 18. So she bought 6 hamburgers. Again, you always have to come back and figure out what you have assigned Y value to. Y is assigned to hot dogs. The question is asking how many hamburgers she buy. That means X has to be 6. Okay, this is a final video, a final problem in this video. This is one of my favorite problems. And if you notice, for the first time, I've shown you the answer choices in this sequence of videos. Why? Because I want to show you a trick. In some cases, you may be able to use, of course, if it's a multiple choice, there's going to be an answer choice. If the question is a multiple choice problem, occasionally you may be able to use the answer choice to work your way back to solve the problem. So before we look at the choice, let's look at the problem. This year, Amy is 3 years older than Jackie. In 6 years, Amy will be 2 times older than Jackie. Okay, how old is Jackie today? So first, let's write the names, Jackie and Amy. Okay, let's write today. Okay. Okay, now again, I am going to take Jackie to be, say, 12 years today. Okay, if Jackie is 12, I've solved the problem, so I know. If Jackie is 12 today, okay, what is Amy's age? Okay, Amy is 3 times older than Jackie, right? If Jackie is 12 today, like this year, that means times 3, right? Which means Amy is 336, right? In 6 years, that means, well, they both will have to add 6 to their age, right? So it'll be 28, right? And then 42, right? In 6 years, Amy will be 2 times. That won't work, right? You see, in 6 years, is it? Well, that's not 2 times, is it? So if Jackie had been 12 in the current year, then how old is Jackie today? Is this is not working, right? In 6 years, the calculation has to match. Okay, it's not matching. So let's take half of 12. So if Jackie is 12 years today, that is this year, that means Amy is 18, right? Times 3, right? And in 6 years' time, Jackie will be 12 and Amy will be 24, right? Fast forward 6 years. The calculation works. Amy is 2 times older than Jackie. Okay, let's continue. So again, Jackie, I'm going to say Jackie at the top and Amy in the bottom. And this is today. Okay, that is this year. What if it is 18? That means it's 54 for 18, yeah, 54 for Amy. And 6 years time, Jackie will be 24 and Amy will be 60. 24 is not 2 times, so that's won't work. And then again, let's start with Jackie being 10. That means Amy will be 30 in 16 and 36. 16 times 2 is not 36, so this won't work either. This works, but this is. So the only condition that satisfies all of this is, that means Jackie is 6 years today. That is this year. Does that make sense? I mean, of all the problems, I like this particular problem because when I read the problem and the answer choices like were literally on my face, and I said, okay, let me go ahead and do it this way. And this actually didn't take me that much time than doing it a proper logical way. So if you feel like this may be a little too long, then let me know how you would do it in the comments box below. If you've learned something, consider subscribing to my channel. I'll be posting more content on SAT and ACT math problems. Consider subscribing to my channel and share the video with your friends who are also learning SAT or ACT. And I'll see you with another video on system of equations. So stay tuned.